igcse Physics Radioactivity Part 2 Paper 1. In a nuclear reactor, a uranium-235 nucleus absorbs a neutron and fission occurs. Complete the equation below that shows a typical fission reaction. 235, 92 atomic number, 1, 0, and we have to fill in the blank. So 56 is the atomic number of barium, and 235, 92 are the mass number and atomic numbers of uranium. 142 is the mass number of barium, atomic number is 56. 91 is the mass number of krypton, and 36 is the atomic number, proton number of krypton. This is because 235 plus 1 is 236, minus 3 is 233, minus 142 is 91. That is the mass number, and barium's atomic number is 56. So for 1A, the answer is 91 and 56. Okay, let's go to B. Explain how nuclear fission can lead to a chain reaction. So neutrons are released, and after they're released, they are slowed by the moderator, so that they can be absorbed by other uranium nuclei. That would cause further fissions. So that is a chain reaction, and because it's a chain, so it will keep on going. So again, after further fissions, neutrons are released, and then all again. This is a nuclear reactor. This is the diagram: coolant out, coolant in, and uranium rods. Diagram: label the control rods and the shielding. This is the shielding, and the control rods are these rods. So correct labels for control rods and shielding. So yeah, this is the shielding and these are the control rods. Explain why shielding is needed. Shielding is needed because there are radioactive. This is a radioactive waste, and there may be some tissues. I mean, humans have tissues, right? So if someone's near there, and it can cause cancer and etc. Ionizes cells. So the reactor material slash waste, the material slash waste is radioactive. It can ionize cells or the tissues, organs, if anyone's around or like that. Radiation ionizes cells. Radiation is very penetrating, so a thick shield is needed. The table describes the nuclei of 4 atoms. Which nucleus needs the largest number of electrons to form a neutral atom? So protons equals neutrons. The most protons is americium, 95. So the answer is americium 238. Which two nuclei have the same number of protons? The atomic number of these two uraniums, of course, cause uranium and uranium. Different isotopes. Okay. Which two nuclei have the same number of nucleons? So the mass number, protons plus neutrons, it must be the same. This mass number is the same for plutonium and americium. And which two nuclei have the same number of neutrons? Let's see. So uranium and americium, let's check. Yeah, uranium 235 minus 92 will be equal to 238 minus 95. So that's why uranium 235 and americium 238 have the same number of neutrons. All of the nuclei are unstable and have a different half-life. Explain what is meant by the term half-life. So half-life is did I skip a question? Oh, sorry, yeah, I skipped the question. Explain what is meant by the term unstable. So it will decay slash emit radioactive particles or gamma. So gamma radiation and alpha and beta. So it will decay slash emit. It will decay or it will emit radioactive particles. What is meant by term half-life? A time taken for half of the radioactive nuclei atoms isotopes to decay and break down, or for radioactivity to half. Why when plutonium decays, it emits an alpha particle and a gamma ray. Complete the decay equation for plutonium 238. So this is 2 alpha particles have 2 protons, 2 neutrons. So 2 protons plus 2 neutrons is 4 mass number. And this is 234 because 238 minus 4 is 234 and 294 minus 2 is 92, and this is identify element X. This is 0. This alpha. Anyways, what is element X? So we can find with the 92 atomic number is uranium. Okay, and the nucleus of americium 238 can absorb an electron. When this happens, one of the protons in the nucleus becomes a neutron. This equation describes the process. So 1 neutron plus an electron turns into a neutron. 1 proton plus electron equals neutron. Describe how this process affects the proton and the nucleon number of the nucleus that absorbs the electron. So a proton changes to a neutron, so there's 1 less proton, so the atomic number is decreased by 1, whereas since there's a less proton but there's 1 more neutron, so the mass number, nucleon number stays the same. Proton number decreases, nucleon number, mass number remains the same. Identify the new nucleus formed by this process. So americium 238. Americium's atomic number -1. It would be plutonium 238, as the nuclear number stays the same. And next question. The grid shows the number of neutrons and the number of protons in some isotopes formed during successive radioactive decays. What are isotopes? Isotopes. Nuclei / atoms with same number of protons, same atomic number, different number of neutrons, or different mass number. Those are isotopes. Why are some isotopes described as stable? So stable isotopes do not emit radiation, ionizing radiation, or stable isotopes do not emit alpha, beta, and gamma radiation. Do not emit ionizing radiation or alpha, beta, and gamma radiation. Use the grid to calculate the number of neutrons in a 210. Oh, this one. Okay. 210. It will be 84. Number of neutrons. Okay. So over here. 210 is the mass number. Minus 84 is 210 minus 84 is 126. That is the number of neutrons. Describe what happens to the number of protons and the number of neutrons when the nucleus of 10 PV decays to form 2. Oh, so number of protons. So decays, so it breaks down. Breaks down the neutrons, turn into protons plus electrons. So what happens is a neutron is broken into electron plus proton. So a proton number is increased and neutron decreases. Say the type of decay. Type of decay occurs when this turns decays to form this. Since electrons are beta, right? So it's beta decay. Because it decays to form this. So it changes the atomic number, it increases it by breaking down the neutron, and electrons are radiated beta, and that's beta radiation, beta decay. Okay. Explain why the nuclear number and the atomic number do not change when a gamma ray is emitted from a nucleus. So gamma is not a particle. They have no rest mass, do not have a proton number, do not have any protons or neutrons. Gamma rays are electromagnetic radiation or energy. No particles are lost from the nucleus when a gamma ray is emitted. Radon is a gas produced by some types of rocks. Radon is a natural source of radioactivity. What is the name for this radioactivity? So it is a gas produced by some types of rocks, and radon is a natural source of radioactivity. So it's already there in the environment and all that. it will be counted as background radiation. So background radiation. There are two sources of alpha radiation in some houses: radon gas in the air, solid americium in a smoke alarm. The alpha particles from radon are a greater risk to health than the alpha particles from americium. Sorry about that. So the alpha particles from radon at a greater risk to health than the alpha particles from americium. Why is that? It is because radon is a gas, so particles or the atoms are mobile, they move around, whereas the americium is solid, particles and atoms stay in place. So radon can be inhaled and damage internal tissue, whereas radiation from americium stays within the smoke detector, absorbed by the plastic. So that is 4B. In this question, radon 222 and radon 220 are both isotopes of radon. A nucleus of radon 222 has 86 protons. How many protons are there? Obviously, in radon, it would be the same proton number. So 86. 86. And for this question, 222 is the mass number, minus 136 is, oh sorry, 136 is the neutrons. So if minus 2 over here and it remains radon, then minus 2 over here, which is 134, and it is 134. Next question. Complete the graph by adding the missing unit of activity. The unit activity in BQ or becquerels. I guess that's how it's pronounced. Somewhere. Explain what is meant by the term half-life. Time for halving, time for 50% decrease of activity or radioactivity, number of radioactive atoms, number of radioactive nuclei, or emissions. Need radioactive nuclei or emissions. So find the value for the half-life of radon 220. So this is radon 220. It's 700. It half would be 350, and it's about 1, 2. It's about, yes, 50. Oh, wait. It's half of 700, 350. It seems like it is over here. So I think it's 55. Yeah, it's 55. Anyway, so 55 plus or minus 4. The scientists use the radiation term in different ways. So match this. Electromagnetic waves are gamma, particles with a negative charge are beta, and particles with a positive charge are alpha. So yeah, particles with a positive charge are alpha. Alpha, beta, and gamma radiation are described as ionizing. Complete the table to show alpha, beta, and gamma radiations in order of increasing ionization. So gamma, beta, and alpha. So the order is gamma, beta, and alpha. Two ways in which these ionizing radiations can cause harm. There is can damage cells, and any two from these three. One of them could be can damage cells. Another one could be can cause mutation, can cause cancer mutation, and damage to cells. Okay, and next part C. People who work in People who work with ionizing radiations need to measure the amount of radiation they are exposed to. So complete this table either using goes through or stopped. So alpha radiation is stopped by paper and stopped. Metals will stop alpha and beta. So aluminium will stop alpha and aluminium will stop beta. Lead will stop alpha, lead will stop beta. But beta can go through a 0.1 centimeter piece of paper, but gamma can go through all of those. Alpha is stopped by all, and beta can go through this 0.1 centimeter of paper. Say the name of another device that can be used to detect alpha radiation. Geiger GM tube, thin window GM tube, a cloud chamber can detect alpha radiation, and a spark chamber semiconductor detector. So those can detect alpha radiation. Alpha particles, beta particles, and gamma rays have different properties. Tick in these boxes for each property. So alpha is most ionizing, and alpha has largest mass. Gamma is most penetrating and has the highest speed, and beta is negatively charged. So these two most ionizing, largest mass, alpha, and most penetrating and highest speed. So it goes through a lot of objects, and like easiest to go through a lot of objects. It penetrates and goes through. So that's gamma, and also highest speed is a gamma. It's a wave rays. Negatively charged is beta particles that are electrons. And for part B, say the number of neutrons and number of protons in an alpha particle. Protons 2, neutron is 2 in an alpha particle. 2 and 2. Suggests why alpha radiation is more ionizing than beta or gamma radiation. Charge is larger than other radiations, and mass is larger than other radiations. So charge is larger and mass is larger. That is why it is more ionizing, because charge is larger. There are two protons, so a positive 2 charge, and it has a larger mass, called mass number is 4. Okay, next one. Smoke alarm contains a source of alpha particles and a detector. The alpha particles use the detector through a sample of air from the room. The alarm sounds if there is a sudden drop in the detector reading. This is a graph. Shows changes in the detector reading. Alarm sounds at this point. This time. Why is the detector reading never zero? There is background radiation. Idea of background radiations. Why is the detector reading never constant? Radioactivity is random. Idea that radioactivity is random, that's why the reading is never constant. Suggests why alpha suggests why fewer alpha particles reach the detector if there is a fire. So the particles are absorbed or deflected or stopped or scattered by the smoke. That is why fewer particles, alpha particles, use the detector when there's fire, if there is a fire. Thank you.